Okay, you should have a sheet at the end of your table. Actually, now it should be next to you. We're going to take some notes here on functions. Okay. All right. So first, we're going to identify the dependent and the control variable. We did talk about this way back in chapter 2, but we'll review it again here. So it says Jerry is driving his car at 45 miles an hour. The longer he drives, the farther away from home he is. Okay, so to decide if something is a dependent variable or a control variable, we've got two things going on here. We've got the longer he drives, and we have farther away from home he is. So we've got two things going on here. So we need to think what depends on what. Okay, so how far away from home he is going to depend on how long he's been driving. Okay? All right, in science, I think they have you say in the wild here, okay. I think they have you say the dependent and the independent. Okay, that's fine. If you'd rather use that phrasing, it's totally fine. It means the same thing. But the dependent variable is going to depend on the control variable. The control variable is what controls the situation, if you want to look at it that way. Okay? All right, the next one we have Kim is reading a biography. The more chapters she reads, the fewer pages she has to go to finish the book. Okay, so on your sheet here, we've got the dependent variable is the number of pages she has left. Ugh. Okay, so the number of pages she has left depends on how many chapters she's read. Okay, so again, you're just trying to figure out, first of all, what the two things are, what the two variables are, and then figure out which one depends on the other thing. If it depends on something else, it's the dependent variable. If it's controlling the situation, then it's your control variable. Okay, on our graph, the control variable is going to be on your x-axis, the dependent variable is going to be on your y-axis. Yesterday when we did the scatter plots, okay, this was our L1, this was our L2. Okay, if that helps you visualize it at all. All right, and I know this turned out a little better on your paper, so look at your paper on this one. We've got an example. A graph would compare the time of day and temperature. Okay, so I've got time of day across the bottom, temperature up the side. So time of day is going to be your control variable, and temperature is going to be your dependent variable. Okay, so that's what we put on the x and the y axes. So the temperature depends on the time of day. That helps you decide which one is the dependent variable. Another phrase they're going to use, it means the temperature is a function of the time of day. So when I ask you to write that, just think about, okay, well, if it depends on it, then it's a function of it. Okay? Definition of a function, it's a relationship in which there is only one value of the dependent variable for each value of the control variable. So for the previous graph, okay, back here, for the time of day and temperature graph, there's only one temperature for each time of day. Okay, so every time of day only has one temperature. At 1 a.m., it's -4 degrees. At 2 a.m., it's a little bit less than maybe -7 degrees. At 8 a.m., it's around 2 degrees. So there's always only one temperature for each time of day. That's a function. Okay? So at the bottom, again, I wrote my sentence, therefore the temperature is a function of the time of day. Okay? A function can be represented in many ways. It can be written in words, it can be written in symbols, it can be determined with a table of values, or with a graph. So let's try two of those here. It says Tracy is going to save some of the money from her summer job. She plans to save $1 the first week, okay, $2 the second week, and then for the next 5 weeks, match her savings to her total savings from the previous week. Okay, so what that means is if she's got, okay, you've got this on your paper, right? So if she's got the third week, okay, we're going to add this up, so that's $3. Oops, I kind of got wild there. For the fourth week, it's now going to be 6, because it's 3, 4, 5, 6. She's matching her previous savings. So the fifth week, she's going to match this, so she's going to save 12. The 6th week, 24, and then the 7th week, 48. Okay, so this is looking at it in a table of values. All right, with a graph, let's take that same information and let's put it in a graph. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, we got 9 weeks. All right, so for the first week, she saved $1. Second week, she saved $2. Third week, she saved $3. Then we're going to start to bump up a little bit. Fourth week, she saved $6. Fifth week, she saved $12, about right there. Sixth week, $24, and then the 7th week all the way up to $48. Okay, this is a function. Okay, so it says tell whether the graph is a function. Yeah, that's a function. Okay, because for every week, there's only one amount of savings. Okay, so that makes it a function. Okay, there's something called the vertical line test for functions. This helps you just visually look at it, like if it's in a graph, and be like, yep, that's a function, or no, it's not a function. And the way we do that, it's a test. It determines if a graph represents a function by looking at it. For each value of the control variable, or for every x, okay, on your horizontal, there should only be one value of the dependent variable for your y. This means that no 2 points of a graph of a function lie directly above each other. Well, we can prove that back here. Okay, there's never any point directly above it, right? Because there's only one savings for every week. Okay, same back here for the time of day. There's only one temperature for each time of day, so nothing lies vertically above it. So there's 2 examples right there. All right, a parabola would be another one. If you remember the parabola, it always gets wider and wider. It may look like there's maybe a vertical line in there once it gets up here, but it's not. It always gets wider and wider and wider. A V-shaped, remember we talked about that. Oh, it's just being weird. Okay. All right. A horizontal line would be a function. A diagonal line is a function. We could have a scatter plot like we did yesterday. Okay, as long as no 2 points lie above each other, it could be a function. What else could we have? Let's see, V-shaped. Well, that covers it. I think there's another one here. So if they're not functions, oh, here's another one. Okay, that would be a function, because again, it's not lining up vertically, nothing lines up 2 points above each other. But if I turn that on its side, okay, now I've got points that line up vertically, so that means it's not a function anymore, okay? If I turn that parabola on its side, now I've got points that line up vertically, it's no longer a function. If I turn that line this way, okay, all of my points are lining up vertically, so it's not a function, okay? The V-shaped, I suppose, if we turned it on its side. The parabola, we turned on its side. The scatter plot, okay, so let's say we're doing this, and let's say we end up with 3 points that line up vertically, okay? Now it's no longer a function, okay? So just basically be able to identify yes or no if something is a function just by looking at it, and then also know your definition. Okay, and then that should get us through. I also have your steps for when we do the scatter plot on the graphing calculator. So if you didn't already get that down, make sure you write that down because you'll need it for today.